Good afternoon, guys. I'm going to continue where David left off. Not David, sorry, excuse me. Where Dr. James Jenna left off. Okay, I'm going to start with we are doing superposition and standing waves, and I'm going to start with question number 17, if I'm not mistaken. Okay, now let's see. Let's pull up the question 17. I'm going to show it now. Okay, there it is. Question 17. Okay, 17. I really like writing on this board. It's really nice. So question 17 asks the following. The fundamental frequency of fundamental frequency above middle C on the piano is 440 Hertz. This is the tenor high A, but a convenient note in the mid-range of women's voices. Okay. So the fundamental frequency of an above middle C on a piano is 440 Hertz. This is the tenor high A, but a convenient note in the mid-range of women's voices. Okay. Now, when we calculate the wavelength, we find that it is. So this question is basically asking us to calculate the wavelength of this above middle C note on a piano, which is 440 Hertz. Okay. Now, let's calculate this wavelength. We know that wavelength is equal to velocity divided by frequency. Okay. Now the velocity is 343 meters per second, while the frequency in this case is 440 hertz. Therefore, the wavelength is 0.78 meters. Okay, if you were to punch that into the calculator, you would get 0.78 meters. Okay, now I'm not going to test how well you can punch in stuff on a calculator, so let me rather just show you as well that I'm not sucking this out of my thumb. Let's see, there we have 343 over 440 gives us 0.78 meters. Okay, so we have definitively proved that the wavelength of this note is 0.78 meters or 78 centimeters. Okay, so slightly longer than two rulers packed back to back. Okay, now I want to check here. Okay, it's streaming nicely. So 78 centimeters. Now, this is it much shorter than the length of either a man or a woman's lip? No. Shorter than the length of a man's lips, but about the length of a woman's lips? No. A person's lips is about 3 centimeters, 4 centimeters at most. This is 78 centimeters. Is it longer than a woman's lips, but about the length of a man's lips? No. Much longer than the length of either a man or a woman's lips. There, it's much longer than the length of either a man or a woman's lips. Let's see if that is correct. Yes, it is correct. Okay. Let's go and continue with question number 18. Let's do question 18. Okay. Okay. Back here. Too far back. I want a new blank page. Let's go here to my whiteboard. There we go. Start. Okay. Okay, that's the one I'm used to. Okay, now question number 18. Question number 18. This question is based on the pressure of helium gas. Okay, the variation in pressure. Now we have seen a formula, or you should have seen a formula that relates the change in pressure to the pressure max. If I remember correctly, I'm trying to recall from memory. The cosine or sine, either one, and kx plus wt. Okay, this formula is the general case for the change or the variation in pressure for a wave in air. For not for a wave, sorry, for a medium. Change in pressure for a medium through which a sound wave will travel. Okay, now let me erase this. This question asks or tells us the variation in the pressure of helium gas. So this is helium gas measured from its equilibrium value is given by. So they give us the variations in pressure, and they give us according to this formula. The change in pressure is equal to 2.9 times 10 to the negative 5 times the cosine. Okay, let me just rewrite it here. That's 18. So the change in pressure equal to 2.9. It's 2.9 times 10 to the negative 5 cosine of 6.2 x 6.20x minus 3000 t. So that is the change or the variation in pressure is given. Okay, so the variation in pressure of helium gas measured from its equilibrium value, and they tell us that the distance x and the time t is in meters and seconds respectively, and that this variation in pressure is measured in newtons per meter squared. Now determine the frequency in hertz of the wave. Okay, now this is the k value and that is the angular frequency value. So this is k, the k value, the angular wave number, and this is the angular frequency. So that's the wave number and that's the frequency. Now we know that angular frequency is also equal to 2 pi times normal frequency. Okay? Therefore, frequency, which we want, is equal to the frequency that we want is equal to the angular frequency over 2 pi. Now the angular frequency in this case is 3000 hertz divided by 2 pi. Let's see if we divide it by 2 pi how much we get. Let's clear this. Angular frequency, let's first 3000 rads per second is the angular frequency divided by 2 pi. That gives us 4,477 hertz. 477 hertz. Let's see if we have an answer. 400 and there we have 477 hertz as the answer. Question 19. Let's clear this. Question 19. Remember, these are all problems on standing waves, resonance, and sound. Now, question 19. They ask, the velocity of sound in seawater is 1.53 times 10 to the 3 meters per second. Find the bulk modulus in newtons per meter squared of seawater if its density is 1,03 times 10 to the 3 kilograms per meters cube. Okay, now we need a formula that relates velocity to the bulk modulus. So we know one of these formulas. It states that the velocity is equal to the bulk modulus over the density, and the square root of that answer would give you the velocity. Now we don't want, we have the velocity, we want the bulk modulus. So if we rearrange this formula, we get that it is the velocity in water squared multiplied by the density of water, seawater, will give us the bulk modulus. Now the velocity in water is 1.53 times 10 to the 3 meters per second multiplied by, or if I forget, you square that and then you multiply it by the density of water, which is seawater, which is slightly more dense than regular water. Now if you multiply that out, you get that the answer is equal to 2,36 times 10 to the 9 newtons per square meter. Now this is approximately, note approximately, equal to 2.4 times 10 to the 9. Now let's see here. We have a 2.5, a 2.1, a 2.04, 2.4 there. That's the closest one. Now, due to rounding, our answers may differ. So that is indeed the correct answer. Question 20. Question 20. To decrease the intensity of the sound you are hearing from your speaker system by a factor of 36, you can, okay, so we want to decrease the intensity of sound. So the intensity of sound by, they say, reduce amplitude or increase distance, amplitude and distance, amplitude and distance. So they want you to take into account amplitude and distance. Okay, so we know that intensity is equal to, or rather, intensity is proportional to the square of the amplitude. So that intensity is proportional to the square of the amplitude. But intensity is also proportional to 1 over the square of the distance. So in general, intensity is proportional to square of the amplitude, square of the distance. So intensity is proportional to the square of the amplitude over the square of the distance. Okay, now let's put in each of those values there. Okay, so we have said that intensity is proportional to Square of the amplitude over square of the distance. Now let's put in each one of those options there. They say reduce, they wanted to reduce by a factor of 36. So let's take for number one, option number A. Not one, it's option A. Let's put in option A. Reduce the amplitude by a factor of 12. So we reduce the amplitude by a factor of 12. So intensity is proportional to, this is the original intensity. So if we reduce the amplitude by a factor of 12 and we increase the distance by a factor of 3, let's see, this, what is it equal to? That is 1 over 2, 1/12. Let's just calculate what 1/12 is, and that's 9. It'll be a over d squared still, a squared over d squared. But what is going to be here in front? It's going to be 1/12 squared over 9. So it's going to be, and we have 1 over 12 1 over 12 squared over 9, which they don't give the answer in fraction form. 12 is 44, so 9 times 144, we just 9 times 144, 1000. So it's 1 over 2, 1 over 1296. This is how much the intensity is lessened if we reduce the amplitude by a factor of 12 and we increase the distance by a factor of 3. Let's say B. Same thing we do it. Same thing we did in A, we do in B. They say reduce the amplitude by a factor of 4. So 1 over 4 A squared, and we increase the distance by a factor of 3 squared. So yet again the answer will be A squared d squared. But what will this answer be? It will be 1 over 16. 16 times 9. That's 144. So it's 1 over 144. C. Proportional to. Let's see what C. They say reduce the amplitude by a factor of 2. Reduce the amplitude by a factor of 2. So a half A squared. Oh, and then increase the distance by a factor of 4. 4d squared. We are still left with A squared over d squared there. And that fraction becomes 1/4 multiplied by 16. So 4 times 16. 4 times 16, that's 64. So it's 1 over 64. Now D, let's see D. I is proportional to, number D, we reduce the amplitude by a factor of 3. So 1 over 3. Sorry. We reduce the factor by the amplitude by a factor of 3. 1 over 3 squared. And we increase the distance by 4. 4d squared. That gives us 9 times 4. 9 times 4 is 36. No, sorry. Times 4 is 36. So the answer is 1/36 of the original amplitude over d squared. So to get a 36th of to decrease the intensity by a factor of 36, you need to reduce the amplitude by a factor of 3 and increase your distance by a factor of 4. Okay, and let's check that answer. No. Which one was it? A over D, 1, 2, 3. Okay, no, it's the next one. This is not, that is 1, 3, 9 times 4. Let me check. Reduce the amplitude by a factor of 3. Okay, this is a factor of 3. D is a factor of 3. So that's 9 times 4. 9 times 4 is 36. Reduce the amplitude by a factor of 2. That's 4. That's 9 times 4. I made a mistake here. I guess. Right one. They say the correct answer. Increase. Well, I made an error. Let's check C. C, reduce the amplitude by a factor of 2. What did I do here? And increase it by a factor of 3 here. Sorry. Here, this one becomes 16. So it's 16 times 9. This one should not be correct. It should be this one here. Number C, I wrote down wrong. Okay, can you see that? A half. It should be reduced by a factor of 2 and increase the distance by a factor of 3. So this distance here was written wrong. Let me just redo C. It's reduced by a half, but increased by a factor of 3. That will give you 1 over 36, which is what we want, a squared over d squared. Okay, that is the one I missed. I don't know what I wrote there, but I made a small error there. So the answer is C. D should then be answered. This is C. D's answer is then, let me see what happened. It's reduced by a factor of 3, so it's 9 times 16. 9 times 16. So D would be equal to 9 times 16, which is 1 over 4. I just wrote the wrong values down. So this answer should not be D, it should be C. The answer for 20 is C. Sorry, my bad about that. Little error there. I wrote the wrong value. I read the right question, wrote the wrong values down. Okay, so the answer is C. Question number 21. Which of the following does not have a definition in terms of the physical properties of sound waves? Okay, so frequency is the number of oscillations that occur per second. So frequency does indeed have a precise definition. Intensity is the power per unit area. So it does have a definition. Loudness is just a term which we use to describe the intensity. So loudness does not indeed have sound level. We can calculate wavelength is the distance between two concurrent crests or 2 points in phase on a wave. So loudness is the one that does not have a precise definition. Loudness. So 21 is C, loudness. Okay, let's continue. Maybe I'll do this tomorrow. Okay. Thank you guys for joining in. I wish you guys all the best. And from me and the rest of the Yellow Physics team, just keep on studying and all the best for your exam. Tomorrow I will be continuing with question number 22. So enjoy the rest of your afternoon. Whenever you're watching this, enjoy or at least I hope I have taught you something. All the best. Thank you.